a mortality with one of the young billies that was collared, so we had to redeploy a collar. So I got to get involved and help with that event, which was really cool as well. Next slide. This was just before that ground survey that we did in the south part of BC. I got an opportunity to go over to the Vancouver Island where Dr. Valerius Geist lives and had a day chat with him. He had a life full of mammal study, mostly behavior related stuff, and he had stories that were just incredible. These two billies that he was holding in this photo, he actually harvested them both as part of a study to determine during the rut how thick the rear part of their hide was in their flanks and stuff, and how much it changed between regular parts of the year and that unique breeding season. And he went on to discuss that at length. And unfortunately, it was only about 2 weeks after this visit I had with him that he passed away. Next slide. This is one unique little story that I can share with, I think there's about 3 photos involved here. You can see this nanny getting pretty rough with this kid. The scenario that was, and you can just see the tips of the ears behind the nanny of another kid. I was out photographing goats in BC, and this scenario was such that there was 2 nannies. One had a single kid and the other one had twin kids. And this kid that's getting abused right here decided he was going to leave with the nanny with the single kid, and the other nanny stayed behind with its kid. And after quite some time of this young kid following the wrong mother, this mother got really tired of trying to convince it that it was supposed to go home, and threw it off a couple of cliffs. And at that point, finally, this young lad decided it was a lost cause and kind of left him stranded up on a fairly precarious ledge. So I was kind of overviewing the scene and trying to figure out how I could positively change the outcome of what was looking to occur. This young one was far enough away from its mother and its sibling, and because the nanny that was looking after the sibling was more keen on looking after the one that it knew was alive than this other one, it wasn't likely going to go and find this one. So if you want to go to the next slide. After much discussion with myself and trying to decide whether it was even safe for me to do so, I climbed out on the shelf where this young kid was and managed to get hands on it and slinked my way back across the fairly precarious edge and brought it back down to where its mother was. And I was quite pleased when I let it go that it kind of went scrambling back towards its mother. And unfortunately, when the mother kind of realized what was going on, it came over in a little bit of a rushed fashion. And this poor young thing thought it was the nanny was coming over to beat it up again, just like the previous one did. And it started running away from his mother. And at that point, they were in close proximity to each other. And there was kind of a natural barrier that kept it from being able to drop any further to dangerous situations. So I, at that point, backed out and left it to happen as it would. And next slide. That's the young kid out on the ledge just prior to me going to get it. And this photo here is several months later when I went back to see the what had occurred or what the outcome was. And here you can see both twin kids are with that nanny again. So it did turn out in a positive way, which I was quite grateful for. Next slide. This is another interesting photo that I took of last time I was out in that same area. You could see the results of rut behavior. This young Billy obviously had a fairly significant altercation with another Billy for dominance for the breeding rights or opportunity in that area, and it was very interesting to watch it and kind of study it as to what it was doing after that. It seemed to be very exhausted and tired, and it must have been a fairly significant altercation because there was lots of blood in the area, and I never did locate the competitor anywhere in the area. Next slide. The rest of these are just general interesting photos of goats in their natural habitat, doing what goats do, crazy things in crazy places. Next slide. And again, some really precious moments with young ones. Interestingly enough, some areas tend to throw quite a few twin kids, and that's not common everywhere, but typically when there's really good forage, they tend to have an opportunity to do that more often. Next slide. Okay, that's the end of my introduction and a brief thing, and we'll get on to the important part of this webinar, the introduction of Jami Belt, who is going to take on the last portion of this webinar. Jami Belt is a biologist at Glacier National Park, leading Glacier's citizen science program since 2006 and has conducted mountain goat research since 2008. She holds an undergrad degree in neuroscience from Miami University and a wildlife biology master's from the University of Montana. As I was kind of reading through some of her history, I noticed that she had aligned a lot of her programs in school to be able to more effectively communicate to people and through people the importance of conservation and such. So it really lined up very well with her end goal or end user. And I was really excited to see all of that work that she'd done prior to get where she's at now. So under Jami, citizen science, over 150 volunteers are the extra eyes, ears, and feet of Glacier's biologists, adding observations about goats, bighorn sheep, loons, hawks, eagles, and pikas throughout the park. She lives in West Glacier, Montana with her 2 sons, where she enjoys running and eating fruit. So with that, we are very, very fortunate to be able to support Jami's passion for citizen science, and specifically for mountain goats, because it aligns synonymously with RMGA's mission and passion. She has also been very giving of her time to help bolster RMGA's citizen science credibility and rigor. And we're just currently trying to really bolster and improve that system where we can more effectively and more consistently deliver that product to biologists. So thank you, Jami, and it's all yours.
Okay, great. Thank you for the introduction. Appreciate it. And thanks for the invitation to speak. So I'm going to share my screen in a second here. My goal is to, I know some of you are more familiar with my work, some are less with the work that we've done here with citizen science in Glacier. So I figured I would just give you an overview of everything we're doing, but I really wanted to share some of the most interesting scientific results that we have churned out recently on our trend analysis for an over a decade-long series of our counts so that I can share with you where we're at with that. So let me get my screen shared. Let's see here. It's this one. Okay. Can you see that? Looks good. Okay.
Yeah,
Okay, great. So for starters, so I'm here in Glacier National Park. We are, I'm sure most of you are familiar with this area, but we're on the border of Canada. So we share a border with Waterton National Park, and we are a 1 million acre protected area and fortunate to have a large intact native population of mountain goats. So in 2008, there was a desire to start looking at mountain goats in a more concerted way. This came on the heels of a citizen science effort that we started looking at common loons in 2006. Common loons, since you guys are people, I'm assuming you all know, but they're a bird species that is pretty indicative of ecological integrity of lake ecosystems. And so we wanted to better understand them and started to broaden our inquiry into that species using citizen science, which had been done in a lot of other places. And so the park wanted to see if it would work in Glacier. And it turned out that people came out of the woodwork. There was 60 people within the first, we had just like a 6-week pilot season in 2005, and discovered that people want to help. They want to get out there, tell us what they're seeing, and bring back information that we can use to, as data, to inform our understanding of species and how to manage them. So in 2008, the park decided that they wanted more information on mountain goats, but didn't have a lot of money to get that information and wanted to try something new. And so tried to springboard off of that success with citizen science, you know, with participation numbers to see if we could look at mountain goats that way. So that was at the time when I entered the scene, was back in 2006. And then in 2008 started the Mountain Goat Project to see if it would work to count mountain goats using citizen science. Oops. Okay. So this is what it looks like. So we recruit and train participants to come. Our participants they come from all different walks of life, but for the most part, they're people who live in the neighboring area. We get a lot of retirees. We also get a lot of young people who are looking to build their resumes, experience. We're starting to get a lot more people, you know, kind of in my age range who I thought were too busy, but, you know, people who are somehow either independently wealthy or have lots of extra time on their hands, or just really love getting out in the park in every spare moment they have. So we have a pretty good demographic now, age range wise. We bring those people in, we train them during a 1-day training. So they learn about the ecology of the species, how to find them, how to use the equipment, how to use the mapping program that we use to get them to the sites and things like that. And then they are free agents to go out to our 37 sites as frequently as they can to help us count mountain goats, with the idea that we can get a lot more replication in a larger area of geographic coverage by using volunteers, rather than having a smaller subset of our sites be able to be counted by our biologists and biological science technicians. So this is what we're doing. I'd like to give an acknowledgement to our traditional homelands. And to back up again to the reason for why this project started in 2008. So some of you are aware that, well, you know, we're starting to see echoes of emergence of information that shows that mountain goats may be declining in large parts of their native range. In 2008, the information that we had that was making us concerned was there were counts being done at the Walton Goat Lick. So that's in the southern portion of the park. It's a mineral lick that they come every spring, and pretty large numbers, and it's pretty easy spot to get to. So it was a pretty easy spot to be monitoring counts over time. And at those counts, there were pretty significant declines being detected. It was just a small piece of information, but enough to make the park want to know more. Additionally, there were counts going on using aerial surveys in the Bob Marshall Wilderness, which is a very large wilderness complex to the south of us. And in that area, they had seen as much as an 85% decline in their numbers. And that obviously signaled great alarm and caused them to change their hunting regulations significantly and start looking a little bit more deeply into what was going on there. So Glacier wanted to know more about what our population looked like, what the status was at that time, and also to try to update the work that had been done in 1988 by Doug Chadwick. I'm sure most of you know who he is. He did mountain goat, some really pioneering ecological studies and counts in a small portion of the park. So, but that had been a long gap from 1988 to 2008 when we started this work. So that was the reason that we wanted to start counting this incredible species. So this is how the study works. So during the time period when mountain goats are most likely to stay put within their home ranges, which is the time between birthing season and the rut, we try to get people to each of our sites at least 3 times so that we can get detection rates for having repetitive visits at each site. I put a grid cell over the park to represent an area that would encompass multiple home ranges so that we would get systematic coverage over the whole park, and then randomly selected trail segments that had goat habitat, mostly slope, and that had distance, visible distance from trails where people could positively identify mountain goats without it being too far. And then once we walked each of those trails, we selected the area with the largest view shed along each trail. And so what people do is they hike to each site using, it used to be GPS, now we use Avenza or Gaia. Any of the mapping programs, people have a layer that they download and they can go and navigate themselves to the site so that everybody gets to the same point on the trail to do their survey from. So this is a site in the park. You can see that little red diamond in the center is where people stand. The pink is the trail. And then that light blue area is the view shed. So that's what you can actually see from that site, which was modeled using GIS and looking at vegetation coverage and things like that. So from knowing how much of a view shed we have in each area, we can use the count to extrapolate a density estimate of mountain goats per square kilometer for the overall counts. And people do a 1 hour point count. So they get to the site, set up a spotting scope, pull out binoculars and do visual sweeps of the area, at least 2 of each quadrant, and then go back to each spot with spotting scopes if it needs to be done to get better looks, and then try to identify by age and sex whenever possible. Oops, hold on. Okay, and then as far as collecting the data, we have evolved to using mobile data collection, which we're pretty excited about. We use Survey 123, so people can take their cell phone, some people use tablets, into the field with them and count the mountain goats, record the locations of the mountain goats. We have base maps on there so they can actually give us a pinpointed location of where the mountain goats are seen, how many there are, what aspect they're on, what type of habitat they're in, and all sorts of things like that that we can then use to look at some habitat analysis and better understanding of what's driving detection rates and abundance estimates. And so here's the coverage across the park. So as I mentioned, we have 37 sites and they're pretty equally distributed across Glacier. The gaps that you can see are because there are not trails in those areas that access mountain goat habitat. So we do have a couple places where we're not able to get thorough enough surveying for those reasons. And I'll go into some of the ways that we're going to try to address that as we get further toward the end. But overall, we have pretty thorough coverage of all of the areas where mountain goat habitat is found. And so the way the survey is set up statistically is we're using an N mixture model. So you're looking at the detection rate of mountain goats at each survey event. So knowing that you might not see the same number, you're likely not going to see the same number of goats in each survey because they're moving around, they hunker down behind rocks, they might go to the other aspect of the mountain that you can't see. So you're going to get a different count history each time you visit a site. And sometimes, even though we know mountain goats are present, you'll have zeros. So the presence, the times that you positively detect presence of goats versus the time that you don't detect any goats gives you detection rate, and you can integrate that over all of the events of surveys and get your detection rate. And then the variation in counts across all sites gets ended over a distribution and it gives us possible values of abundance for all sites so that we can get an average abundance across all sites. So that's how we extrapolate an estimate for average number of mountain goats across all sites each year that we use then for relative abundance to understand trend over time. So when we started the project in 2008, again, the goal was mostly to see, can we do this? You know, the gold standard for doing mountain goat surveys, or at least the most commonly used one, is aerial surveys. The park, we did actually do aerial surveys, which you can see from this slide here. And I'm going to move away from that slide for just a minute because I don't want you to get distracted. So the aerial surveys were something that we wanted to do, and we did do to a certain degree, but to do them with enough replication to get detection rate and to understand what might be driving changes over time was something that we knew we would never have the money to sustain over the long term. Also, the park tries to steer away from doing a lot of aerial overflights because we have undesignated wilderness, so proposed wilderness in the park, and try to, you know, kind of minimize the aggregate number of flights that happen. Also, we know that visitors are not in love with aerial overflights, and the park has been trying to minimize the use of scenic overflights as well. So that was why we wanted to try something different, just to see if it would work, if we could tap into, at this point, the 3 million visitors that we get each year who go into mountain habitat. We'll take tons of great photos of mountain goats. Have, you know, it's one of the places that you can have, one of the most likely places that you can have an easy interaction with mountain goats. And so why not tap into all of those people having those interactions? So in 2008, when we started the project, we wanted to see if we could get people to do it, but we also wanted to see if it worked. We didn't want to launch into a long-term monitoring effort without knowing whether or not it was actually getting to the information that we wanted, which was an understanding of population density and distribution over time, and then to see if it would work for monitoring trend. So in 2008 and 9, I did a study to look at how much work we could get done with volunteers for the amount of money that we had for the grant that we used to develop this project. And then also did a subset of surveys using biologists, basically replicating the same amount of money that we would have had to spend to get biologists to do that same type of work. So what that translated to was biologists went out to a smaller number of sites less frequently because they were, of course, getting paid and the volunteers weren't. With the volunteers, you know, the cost going into the volunteers being the coordination of the program. And then we did one set of aerial surveys to see again if that would compare. So this graphic on the left here, I'm assuming it's not flipped for you guys. Is it the graphic on the left that shows the volunteers versus biologists? So anyway, that's the one I'm talking about. So on the x-axis, you can see the observer type. We have volunteers, biologists, the aerial survey, and then we looked at the estimate, the density estimate that was produced by Doug Chadwick with his work in the 1980s as well. And then on the y-axis is the density estimate in terms of goats per square kilometer. And what you can see there is that the biologist estimate was higher. So there was an ability most likely to see more of the mountain goats out there. You know, I went out side by side with the volunteers quite a lot and saw that, especially when they're new, the search image just isn't strong yet. So it takes them a little while longer to find the mountain goats. Sometimes they're looking for something bigger than what it's really going to look like out there. And, you know, maybe don't see the ones in the shadows and things like that. So there's an ability to see more mountain goats, but because of replication, the volunteer estimate ends up having a smaller range around the estimate. And what we thought was really interesting was that the volunteer estimate was almost exactly the same as the aerial survey estimate, as well as with Doug Chadwick's estimate, which his estimates were mostly based off of 1 or 2 visits to each of his survey sites as well. So that kind of makes sense. So because of that information, we also, I guess I'll point out we did look at distribution differences that were detected by volunteers and biologists. And you can see there are some differences in the density, kind of relative density that you can see, but that overall there's quite a lot of overlap. So because we found that the volunteers were producing information that was similar to what we would get from aerial surveys, the park. And, because of the educational value, the number of people that we were engaging in that and relative low cost of the program, the park decided that that was going to be our method going forward as the primary way of tracking population trend and distribution changes over time. So we've been doing that ever since. One thing that we did find though from that validation study was that, so we were looking for a target threshold change of 30%. So a 30% decline over 3 generations of mountain goat lifespans is what the International Union for Conservation in Nature would use to elevate the population or the status of mountain goats from their current level of least concerned to vulnerable. And so that was what we used to say, that's where we would want to trigger some management action if we saw a change at that level. And what we found was that with the current statistical methods that we had at our disposal of looking at the population density estimates 1 year at a time, it would take us 30 years to detect a population decline of that magnitude, which is better than nothing, but 30 years is a long time to wait if something significant is happening, because at that point you might not be able to do anything about it. And so we wanted to see if we could bring to bear some new methods to see if things had improved or what we needed to do to increase our precision to make it more likely that we could detect population declines. So in 2019, we got a grant to work with USGS with the team led by Tabitha Graves and look at a multi-year population and mixture model that allows us to integrate all of the changes over years and get a much better, more robust estimate. So here's the information that we gleaned from that. So we talked a little bit about using the non-detection versus detection of mountain goats at each site to understand detection rate. So looking at the multi-year and mixture model approach. And I guess just to kind of show you some of the data that went into this. So again, we started the program in 2008 and then did this large trend analysis. We finished it in 2021, but it was using data through 2019. So we actually had 2020 data to bring to bear to that, but the weather variables we wanted to integrate didn't come online until too late. And so we couldn't bring 2020 in. So we had a total of 1,961 surveys. This shows you over time the number of surveys per year. You can see in 2009, we had quite a few more surveys than in the other years. And that was because that was the year that we were doing the specific comparison between volunteers and biologists so that we could understand better how those two things compared. And then an average between 2010 and 2019, we had 147 surveys per year. So an average about 4 surveys per site. Almost all surveys got at least their 3 surveys done, but some surveys had, or some sites had 0 surveys, and you can see which ones those were there. And this is what we learned about our detection using this more robust model. So no binoculars. Sometimes people could go out with no binoculars. We generally omit those surveys, but we wanted to see if it mattered. There's really not that many. I think we had 35 surveys where people didn't use binoculars. But this tells us that those are depressing our detection rate. And so we're going to throw those out in the future. And that's, it seems like sort of a silly thing to even think about, but it would be worth knowing if having binoculars really did matter. It seems obvious that it does, but if it didn't, that could be really helpful because then you could, amplify your effort quite a bit if people could just go out and do it with their naked eye. But obviously that doesn't work. We also, the other thing I wanted to point out, there's a lot of variables here in this detection model, but the one that comes out looking the strongest is habituation. And that's basically, we have habituated goats. We classified each of the sites based on the level of habituation that we see and found that high habituation leads to more detection. Not surprising, the goats are going to hang out often much closer to humans in the areas where they're highly habituated. But that's something that we need to consider as we continue to move forward because we're seeing more and more people getting into the park and more people getting, everybody wants to get really rad and do new things and get higher and go better places. And so we're seeing people much further into mountain goat habitat and need to take into account what that habituation increase is going to do both to the behavior of goats as we manage them through that lens, as well as the detection of them when we do trend estimation. And just as an example of what that can look like, they don't seem to mind and often will come much closer to people than we're used to, and that can change quite a lot about their natural behavior. Another thing that we learned from the detection analysis was that it's really important to invest in your long-term observers. So this graphic shows observer experience in terms of number of surveys. So during each survey event, the number of previous surveys a person had done, and then detection probability on the y-axis. And you can see there's a sweet spot right around 10 where people start to reach their highest detection probability, and then it tapers off a little bit. So we want to really invest in trying to keep volunteers on board, which is hard. Volunteer attrition is just something that happens. So we have to really work hard to try to figure out what the volunteer motivations are and keep our good people on board as long as we can. We also need to look at what time of year to do the surveys. So this shows temperature on the x-axis, and then detection probability on the y, as well as date on the next graphic on the x, and the detection probability on the y. And what you can see is that there is much better detection when it's cooler, as well as in the early part of the spring and later part of the fall. Mountain goats don't like to be out in hot weather. Not surprising, but that is important because we have a really compressed season. So, as much as we'd love to get people out in November and early June, it's really snowy then. It's really hard to get to a lot of these places. And so we have to find the balance between when to get people out at the most detectable times and when it's practical to get to these locations. And this was informative to us because we were doing, as a way to try to coalesce a lot of interest and get people rallied around getting out. We were doing an annual Goat Days event in mid-August. And as you can see from the graphic there, that turns out to be one of the worst times to be sending people out to all the sites in terms of detection probability. So we've decided to scrap that and look at other ways to rally that kind of interest. Okay, and so now we can talk about trend results that we got from the 2008 to 2019 data. So this is the summary here. It's not looking great from this data source. So what we have on this graphic here is the year on the x-axis and the predicted number of mountain goats per site on the y. And you can see that we had a significant decline between 2009 and 10, and then a continued decline as we go forward until we hit about 2015 where things start to stabilize. So looking at the whole data set, we see a 45% decline. You can see the confidence, or these are the credible intervals because this was a Bayesian analysis. We did take out 2008 and 2009 because, as you saw from the earlier summary of the data amount, we had a really large year in 2009 and in 2008. And we were wondering if there was maybe a startup effect. So, people are really excited coming out of the gate, really dedicated. Maybe, people were trying harder. There was also the fact that they were being evaluated. So having biologists, going along side by side with them occasionally, or knowing that the biologists were evaluating their performance. So we wondered if maybe that was having some effect on elevating their detection rate. So we pulled out 2008 and 2009 and looked at that, just the remaining data, and still see about a 28% decline. So that's the summary of what we're finding from the trend analysis. And obviously that triggers concern for us to need to know more. And you can see that 49% of our sites have statistical support for declines. Only 5 had statistical support for increases. And this is one of the ones that has declined. It's 50 Mountain. It's kind of up in the center of the park. Harrison Lake has a slight increase. That's down in the southern edge of the park. And it's a little bit more of a remote site. And then this, I don't want you to blur your eyes too much here, but I thought just kind of looking at the patterns, the median number of goats per site, the higher densities are in red, lower densities are in white. And you can see a few more sites going from darker colors to lighter colors as we go through time. So we also looked at what might be driving growth. So looking at remote sensing variables, looking at a lot of climate variables and habitat type variables. I'm putting this list up here just to show you all the different things we looked at so that you can, kind of start to puzzle and maybe give us some sense if there's other things that you would have thrown in there that we didn't think to throw in there. A lot of it was really just what we had the data to work with and what was relevant to the data set that we were providing. But here are some of the variables that had an effect on growth rate. So x-axis is the effect size in terms of the growth rate, with positives being a positive growth in the population, negative being negative growth in the population, and then the variables on the y-axis. And you can see that the two that come out looking the strongest are the quadrant snow water equivalent, which was what SWE stands for, with an interaction with winter temperature, and then neonatal precipitation. So I'll talk about neonatal precipitation in a second. But what you can see from this other graphic on this slide is that the snow water equivalent of the quadrants has an interesting effect as you get. So as the snow water equivalent is lower, you see much more depressed growth at cooler temperatures than as it gets warmer. So that's something that we need to think about, what that's going to mean as we have differences in how snowmelt occurs and how much precipitation is coming, or how much snow water equivalent is coming down in the precip. Something that we couldn't model that relates to the snow water equivalent is avalanches. And we know that avalanches, and I think Kevin's on this call, and there's some really cool work that they're doing up in Alaska, and then starting to see if we can maybe dabble with that with our data sets here as well. But we know that avalanches are in many places becoming more frequent and maybe larger severity. This was a goat that got knocked down by an avalanche in the southern part of the park. And so it'd be really interesting to know more about how that might be having an effect and see what we might need to bring into our population monitoring to see if we can detect any changes with that. And then this is a graphic showing the effect of neonatal precipitation, so precipitation during the birthing period and the growth rate. So this shows the years on the x-axis, growth rate on the y, and then the neonatal precipitation on the z-axis there. And basically what you should take away from this graphic here is that in years with lower spring precipitation, the growth rate is depressed. And so what we saw during this part of the data set is that the precipitation during that time period was lower. And so it depressed the growth rate. It would be interesting to see, we think that that's not going to be the trend over time. So we'll have to see if that changes, if we start to see more positive precipitation during spring and what that does to the growth rate. So in summary, we had some pretty large declines detected, definitely exceeding the criteria that we set for our threshold. This is consistent with the pattern of kids to nannies over time, and also somewhat parallels the mortality that we've seen with the colored animals that we have here in the data sets, or in the captured population. And as many of you know who are familiar with goats on this call, mountain goats are pretty slow to recover. They're slow, they breed slowly. So it's important when you see a decline of this magnitude, we do know this is just one data set, that there's a lot more work that needs to be done, and we need to bring in a lot more logical inquiry to understand better what might be driving this information. But it's important to learn more soon. So getting a better sense of population size, structure, vital rates where we can, and forage dynamics. And one thing that we're doing as a first step is we're trying to get a better sense of population genetic structure to understand better what is the context of these declines. What is our minimum effective population sizes that's needed to keep the population going? Are we seeing connectivity between our populations? We know that our population in the northwest of the park is probably declining more quickly, and we're not exactly sure why, but we're seeing a lot less. We're just seeing a quicker change in the number of, or the population estimates in those sites. And it's also disconnected from any feeding population, because the goats on the west side of the park that used to exist in the whitefish range have been extirpated since the 60s. So we started collecting mountain goat fecal pellets in 2019 as a pilot study, and then got full funding to do a genetic population structure analysis last year. So we got a bunch of people out collecting mountain goat fecal pellets, again, a citizen science-based effort. We did get biological science technicians as well to fill in the gaps and get places where it's harder to get volunteers. So it's a lot of fun collecting mountain goat poop. And we tried a variety of different methods. We used basically, again, to see what would work best for citizen science. We tried envelopes, dry collection in envelopes, and it worked pretty well. The extraction rate, I believe, was 67%, but with ethanol, we got a much higher extraction rate. I think it was 82%. I'd have to go back and look at our preliminary results. And so we decided to go with ethanol just to increase our, the success of our effort. So that's what we do is we have people go out with ethanol. We have Survey 123 platform that people use to collect the data for that as well. And they can record their transect. So we get survey effort as well and can understand a little bit better what it takes to get the work done, as well as how much ground they're covering. We're trying to get funding to scale it up to a population estimate so that we can also understand what the magnitude of declines we're seeing means in terms of the greater population, because the work that we've been doing with citizen science is really looking at relative abundance. We're not looking at overall abundance. And collecting poop is really fun. You can see it's really exciting. I mean, she was full of joy because it takes a long time to find mountain goat poop. These are some of the Rocky Mountain Goat Alliance volunteers that came and joined us last year. And I think Carla here can attest to the fact that it's not easy. They don't poop as much as they should. At least, in fact, Kevin and I did a really long trip once to try to find mountain goat poop and didn't find a whole lot during that pilot effort. So yeah, when you finally find it, it's like a treasure hunt and it's pretty exciting, and it can work to get to the places where they finally decide to release their dinner.
We were pretty excited when we found ours. And it was right at the very end of the very end of the very end of the trail.
So yeah, and here's a map of the survey effort that was completed last year, pellets collected by our volunteers. We had also pellets collected by biological science technicians, as I mentioned. So we had some of those gaps filled in by the people who were getting paid to do the work as well. And that's it. It's 1 minute before 8. So I don't know if you guys want to stick around for questions, but I just want to say thanks to, of course, all our citizen scientists. The Glacier Park Conservancy does a huge part to support our work, as well as USGS that supported the trend analysis. And then the Rocky Mountain Goat Alliance has given us a bit of funding over the last few years that we've been really grateful for too, especially for the pellet work. So yeah.
Jami, just one question here. What's the dynamics between sheep and goats in that park in terms of their interaction and possible negative interaction?
Yeah, good question. We do have both, and they do overlap. We see them in many sites in the same locations. We haven't seen a whole lot of negative interactions anecdotally, but I don't know if some of you may have seen a paper that looked at interactions at mineral licks and found those were a little bit more dominant at the mineral licks than the. So that's something that would be worth inquiring more into. But yeah, we do see a slight division in their use of the habitat, but it's not something that we can really quantify. There's not been a lot of work done looking at those two things simultaneously. We do have people counting sheep when they're out there, but because the study was designed with mountain goat habitat as the selection factor, we're not really able to use it as a sheep study. That said, it's really interesting. We do have a very distinct cutoff point. We only see sheep really on the east side of the park. We don't really see them ever on the west side.
Do you also have any data for disease in the park at all?
For mountain goats?
Both even. Do you do any investigation or have you had the opportunity to take sampling?
Yeah, so there was some disease work done with sheep in the past by Kim Keating of USGS. I can't remember what year that stopped, but it's been over a decade now. Last year, there was a research team here from the University of Memphis that was looking at bighorn sheep respiratory disease and using behavioral cues to determine whether that might be an effective method for detecting the disease. So apparently they exhibit, kind of droopy ears, less vigilance, more laying down and things like that when they have the respiratory disease. And so that team came here and enlisted our help to recruit volunteers to go side by side with their biologists to see if the observations done by volunteers were similar enough to biologist observations that they may be able to use that as a kind of first line of detection for that disease. So, so that was some work that was done recently. And then with the mountain goat captures that have been done here, over about a decade, in the previous decade, there's been samples taken to look at a variety of different diseases, but I don't think we have detected enough to find anything significant out about that.
Thank you.
Hey, Jami, Jason, Pete, great job on putting all this together. Just a 17-part question I got for you. The first one is, where does all your data go? Where does so you run out and you gather all this data and collect all this stuff. Where are you seeing it most used and its most beneficial use?
Yeah, so we have provided the data to our ungulate biologist here to they use it to understand better what portion of the population was safe to capture. We've used it to look at the way to manage visitor infrastructure, so whether or not we may need to close up areas during the kidding season. Better understanding of the overall distribution of goats has helped us to understand that we need to treat the habitat throughout the park for mountain goats equally, but also a slight bit differently, since the goats on the west side of the divide seem to behave quite a bit differently, as well as the ones on the south portion of the park than the ones on the east side, which may have something to do with the presence of sheep. We're not exactly sure why, but they're definitely different. There's also a lot more vegetation and thick forest on the west and southern sides of the park. So, so yeah, the overall things that has been used for is visitor management, visitor mountain goat kind of minimizing interaction management, better understanding of population overall, and then looking at how to structure further research.
Gotcha. And then as far as RMGA members, where do they go to figure out how they can get involved and help you out and become one of those rock star volunteers you were talking about earlier?
Yeah, so our email address is down here. So we have a website. You can just Google Glacier Citizen Science and it comes up and links you to our page. And then you can email us as well, and we'll put you on the inquiry list. For people who don't live in the area, we tend to try to schedule a few outreach events. So like last year, we worked with the Rocky Mountain Goat Alliance, who came in August. And I think you guys are coming again. We haven't set a date, but we were talking about August again. So that would be an opportunity for people who don't live in the area to come get involved. But otherwise, we do training starting in June and going through about the first week of July. We do multiple trainings, usually one a week during that time period, and people can come get involved that way.
Cool, thanks, great job.
Somebody was asking a question about avalanches. So you'd said that you are possibly seeing increased severity in avalanches.
Mm-hmm.
And is that an increase in the number of avalanches as well, not just severity?
That's the prediction, is that we're starting to see a slight increase in frequency as well as severity as we get higher snow water equivalent and larger fluctuations in conditions over time. Mm-hmm. And warmer falls, kind of hard to get the snowpack to stick to the ground.
Mm-hmm. And I had a question out of curiosity. So Alberta's at an all-time drought, the entire province is in extreme drought levels. And that was all of last summer. We had limited resources, really warm fall, like you're saying. And then we have virtually no snowpack this year. There's maybe an inch or two of snow left at this point, where normally we would have, 3 feet of snow. So one of the things that you talked about was the lowest levels of growth were in the low moisture years. Is that a correlation with just poor grass growth in the spring, and then nannies having less milk? Like, is it survival rate of those kids that you're looking at? If it's growth, I'm assuming, but and just having low forage access for.
Yeah, so unfortunately, we're not able to look at vital rates demographically like that. So we don't, we are having people document when they see young versus adults, females versus males, but that's only a small percentage of the time because we're looking from pretty far distances. So I'm not able to say anything about survival rates exactly, but just growth rate over time. So the overall population. And yeah, the correlation there is that in years with lower precipitation in the spring, there's lower growth, and presumably it's something to do with the forage quality at that time and whether or not, the green up is being fed enough water to maintain its nutritional quality for a long enough period of time, or have enough forage feed the females who are then feeding the babies and feeding the kids and, feeding themselves as well. So just, yeah, probably it affects survival overall, but we can't say that specifically.
Kevin, thank you. Kevin, you had a question.
Yeah, Jamie, just a couple comments and then maybe a suggestion or two, and maybe you're already on top of this with Tabitha. One of the projects that Wild Sheep is funding is working with Pete Capolillo and the Working Dogs for Conservation folks out of Missoula. They have their field station at Tura. They're really getting good with their dog training to detect the presence of Mycoplasma pneumoniae in fecal pellets. And since you say the mountain goat pellets are hard to find, few and far between, you're not sure what animal deposited them. What I'm thinking about and suggesting is maybe, out of every one of those syringes that your volunteers and citizens gather, maybe there's a composite fecal sample that could be sent down to Working Dogs for Conservation, periodically, and have the dogs do a detection trial to see if MOV is present. It is a pathogen that mostly affects bighorn sheep, but in Nevada, in the Tetons, they've also shown mountain goats to have that same respiratory bacteria. So I'm just wondering if that's anything you guys have talked about or thought about or might think about, as it's a really cheap way to just store the pellets, make a composite sample, send them down to the Working Dogs folks. Maybe they can run a trial or two with some of their trained dogs. And to me, it's one way of saying you've got it or you don't have it in a subpopulation or a population. So I just wanted to mention that.
No, that's great suggestion. I wasn't aware that they were able to detect that disease. So that's something that we'll definitely consider and look into the practicality of it for us.
Yeah, maybe we can talk offline, because they've got about a half-page instruction sheet on how to collect, store, label, ship samples. Happy to share that with you.
Yeah, that'd be great. And we expect that we'll continue to collect pellets into the future too, so we can keep collecting more samples toward that effort.
Kevin, Jamie, this is Julie Cunningham. My ears perked up at that. Jamie, great talk. I loved hearing everything you did. But how could they detect respiratory pathogen from feces? What are they passing through the system?
That's a good question, Julie. And, Pete's, some of his folks came to Reno. They presented at that Test and Remove workshop on January 11th. And that's a really good question. So there's something that happens in the digestion and passing process. So they're not sure what the fingerprint is, but the dogs were able to detect that. And so it's not necessarily the bacteria in the pellets, but there's got to be some odor or some stamp that manifests itself in those pellets. And I don't know enough about it, but that's a good question and something they're looking into. It's like they really want to move towards nasal swabs or pharyngeal swabs in addition to the pellets, just to see if there's any difference in detection. You know, if a dog can alert on a swab, but from the same sheep, they don't alert on the pellets. So something happens in that digestive process before those pellets are passed. So good question, still a question mark.
Yeah, that's really interesting. I mean, one of the things that we're also looking at is stress hormones. I'm curious if maybe there's elevated stress when there is a disease population.
Oh, I think so, based on some work that Kevin Monteith at the University of Wyoming is doing. Yeah, they're looking at, you know, body condition and a heightened prevalence of these respiratory diseases in bighorn sheep that are in less than stellar body condition.
One other question we had in the chat, Jamie, was if the avalanche worker community could help provide data, what kind of data would help the study? Specific to avalanches, I'm assuming.
Yeah, that's a great question. Gosh, did I have to think about that? I mean, I think we have pretty good information about avalanches. We have a team that does avalanche forecasting and is doing a lot of work with avalanche modeling here, at least. I think, you know, there's a pretty good, at least in our avalanche center locally here, we have public observations. And so there's a lot of people feeding data into that to help us understand better where avalanches are happening and, you know, sizes of them. They can classify, categorize them based on their size level and things like that. What we really need more information on is where goats are in relation to the avalanches and, you know, what sort of timeframes they're in those locations, and understanding whether or not there's a direct effect of avalanches on mountain goats. So, you know, it'd be great if we had more collared animals. I think that would be a really good way to inform that, but it'd be interesting to see if there's other ways to get at that information without collared animals.
Mm-hmm. Excellent. Any other questions? Oh, go ahead.
I just wanted to see if that answered Trapper's question. All right. Okay, great.
Were there any other questions of Jamie? I know there's a lot of information, technical.
Josh has his hand up.
Josh, go ahead.
I just had a question about the goats moved out of Olympic and over to the Cascades there. What was there a survival rate, or did everything seem to go pretty well? And moving that many goats is a pretty big undertaking.
If you can answer that, I don't know, Jamie. I know that
I'm not familiar with the survival rate, no, of that effort. Is maybe somebody else on this call is more interested.
there's actually a pretty good document on the Olympic National Park site that summarized the number of goats moved, where they were moved to, the survival rate of the ones that they had collared in that transfer. I don't want to guess right off the top of my head what the survival rate was, but it was there was certainly some mortality involved in that transfer. Some during transportation, not too much, but I think more as they were distributed in their new surroundings there over time, maybe not being familiar with that overall area and had some mortalities in that regard.
And I think Julie mentioned in her discussion too about when you bring animals to new areas, the disease occurrence can be higher for the new animals that were moved as well. Kevin?
Yeah, to get at Josh's question, last April in Jackson Hole at the Northern Wild Sheep and Goat Council Symposium, Rich Harris and Patty Happy from Olympic, Rich was working for Washington DFW at the time. They presented twice, and they have manuscripts in, and I think one of his talks was about that very question, Josh, about the survival of those transplanted goats. And so we're working on putting those proceedings together, but I can sure put you in touch with Rich, who could give you some facts and figures and data, and maybe even a draft of that manuscript. So just shoot me an email and I'll put you guys in touch.
I added the link to the document that I was talking about in the chat there as well.
Excellent. Well, thank you, Jamie, and thank you, Darren, for joining us. I'm already planning my summer vacay to be hanging out with Jamie. So last year was the first holidays I'd taken in 2.5 years, and it was well worth the drive. So looking forward to doing that again. So if there is anyone that does want to join us for that goat count, there's also the count with Julie that's being planned tentatively for the 15th and 16th of July for the Bridgers in Montana as well. So Stacy's going to be coordinating all of those, and we hope to see you guys out at those. We're going to be testing our new protocols that our Citizen Science Committee has been developing. And as Darren mentioned, Jamie's had some input on that as well. And last thing is that we have our next webinar. So there's 2 more for sure this spring coming up. March 15th is the next one, and April 19th is the one following. So mark your calendars. Braden Nichols, our regional rep for Washington, is going to be presenting for the next session on March 15th, and you saw him in the photo that Jamie showed. He came to 2 counts last year, and Laura Balix is also going to be talking about her research project that she defended her thesis for last year, which was mountain goat interactions with helicopters. And then on the April 19th, Sandra Hamill and Mallory Lambert are both going to be talking about projects that RMGA has funded. So one is in Alberta, and I can't remember where the other one is, sorry. One's the Alberta project is on population dynamics, and then Mallory's project is on mountain goat and pika interactions. If you have other ideas for other webinars, we would love to hear from you guys, and we have a ongoing list that we can tackle of different projects, so they don't all have to be research based either. Like we had Darren talk about photography and projects he's doing to hear about some fun stuff as well. So, and then Stacy's going to be sending out the recording of this so that you can watch it afterwards if you missed anything, or for people that weren't able to attend tonight for whatever reason. So thank you everyone for joining us. And again, thanks Jamie, I know you're super busy. So
Thank you.
really enjoyed having you.
Yeah, and thanks to Darren. I appreciate seeing your photos and hearing your stories.
Awesome. Thanks, guys.
Okay.
Have a good night.
Well, soon.